In this episode, we're diving into the Combat Core component, the central coordinator of our combat system. Think of it as the brain that manages attack flow, combat windows, and combos. It doesn't directly deal damage or play animations. Instead, it coordinates the timing, tells the hitbox when to start detecting collisions, and makes sure combos chain together. By keeping this logic inside a component, any character can plug it in and instantly gain the same combat behavior. The first thing to look at are the properties that drive this component. We have the attack types array, which holds data about each attack this character can perform, whether it's a light attack, heavy attack, jump attack, or even ranged. Designers can configure this array right inside the editor. Next is the combo tag. This gameplay tag links directly to the montage notifies and our combo animations. When the montage sends out this tag, the combat core knows we're inside a combo window and we can chain the next attack. Finally, we have equipped weapon class and equipped weapon. This allows a component to spawn and manage a weapon actor if your characters use weapons as separate objects instead of just part of their mesh. Even if you don't need weapons as actors, this slot is here to keep the system flexible. When the game starts, Combat Core runs its begin play setup. First, it caches references to the owning character base and the ability system component. Then it loops through every attack in the attack's types array and registers gameplay tag events for them. Why is this important? Because abilities will add and remove these tags at runtime, and the combat core is listening. When a tag is applied, that means the combat window is open, usually tied to a section of an animation montage. When the tag is removed, the window closes. This is how we sync animation timing with gameplay logic. It also registers the combo tag if one is set, so it can listen for chaining opportunities. And if a weapon class is configured, this is where the weapon actor gets spawned. At the end of the begin play, our combo index is reset to 0, so we start fresh. Now let's look at the helper functions that make abilities fire. The most important one is the activate ability by tag. This is called when the player presses an input like light attack. Combat Core finds the matching entry in the attack types array and triggers the ability on the ability system. If a combo window is already open, this function knows to advance to the next combo step. By increasing the combo index, it then looks up the next attack, and if one is found, it activates that instead. If no follow-up is defined, the combo is reset. We also have cancel ability by tag, which does exactly what it sounds like. If an attack needs to be interrupted, Combat Core can cancel it based on its gameplay tag. These helpers keep the player character class clean because all it has to do is call into Combat Core with the right tag. Combat windows are the periods when hit detection is active. The function handle attack window tag change listens for gameplay tags being added or removed. When an attack window opens, Combat Core broadcasts a delegate called onCombatWindowOpen, passing along the attack data. Other components like the hitbox component subscribe to this delegate to know when to start checking for collisions. When the tag count drops back to 0, Combat Core broadcasts on combat window close, telling the hitbox to stop. The same idea applies to combos. Handle combo window tag change broadcasts when chaining is possible or when it ends. This creates a clean separation. Animation simply fire tag. Combat Core handles the logic and other systems just react. Combos are handled through a few simple but powerful variables. Current combo index keeps track of where we are in the sequence. Get next combo attack looks up the next valid move using the attack type and index. Reset combo clears the combo back to 0 and closes the window. There's also a combo reset time, which is a tunable value designers can change. If the player doesn't press the attack button again within that window, the combo automatically resets. This keeps gameplay fluent while still giving players a chance to chain their attacks. Combo Core also provides a library of helper functions to find attacks quickly. We can get the first attack of a given type, like the first light attack. We can fetch all attacks for a given hand, like everything in the right hand. We can grab an attack directly by its gameplay tag, and we can look up a specific attack by both type and index. These helpers make the system very data-driven. Instead of hard-coding moves, our other systems like the player character or UI can simply query Combat Core for the right attack data. The Combat Core isn't limited to melee combat. The function getEquipWeaponData returns information about the weapon currently being used, like damage or special effects. And for ranged combat, we have draw bow and release bow. These map directly to player inputs, and under the hood, they just tell the ability system that the bow input has been pressed or released. This design means we can expand combat beyond just swords and fists. The same system supports bows, dual weapons, or any other weapon type we add later. One of the strengths of this design is how the Combat Core communicates with the rest of the system. It broadcasts 4 key delegates: on combat window open and on combat window close, on combo window open and on combo window close. The player character binds to these so it can start and stop hit detection when needed. The HUD could also subscribe to show indicators when a combo window is active. By using delegates, we decouple the Combat Core from specific systems. Any component can listen and respond without Combat Core needing to know about them. Now let's shift from code to blueprints. Every ability blueprint in the project is built on one of 2 base classes. PGAS GameplayAbilityBase is the foundation for standard abilities. It gives us helpers to add or remove gameplay tags and caches useful resources like the character and movement component. PGAS GameplayAbilityMontageBase is for abilities tied to animations. It manages montage playback, automatically ends the ability when the montage finishes, and gives us blueprint events for notify, begin, and end. By inheriting from these base classes, our blueprints stay lightweight. We don't rewrite boilerplate logic, we just add the specifics for each ability. For example, a light attack blueprint will simply use a montage to play, apply a stamina cost, and rely on the base class for everything else. Abilities also need gameplay effects to apply cost or results. The most common one in this project is PGAS GE Instant Stamina Reduction. This effect is configured to apply instantly with a set by caller magnitude. This means each ability can decide how much stamina to drain. When an attack ability runs, it applies this effect to reduce the character's stamina pool. This keeps stamina costs consistent and easy to manage. Every attack simply applies the stamina effect, but with different magnitudes. It also ensures multiplayer sync, since GAS replicates attribute changes automatically. To recap, the Combat Core component orchestrates combat by listening to tags, managing combos, and broadcasting events. Abilities are executed through our base blueprint classes, while effects like stamina reduction keep combat balanced. In the next episode, we'll move on to the combat hitbox component, where attacks actually connect with the world and apply damage. That's where combat really starts to feel alive. If you found this content helpful, go ahead and hit that like button. It really helps more people discover the channel. And don't forget to subscribe and ring that bell so you'll get notified when the next episode drops. See you guys later.